Hi, hello. Welcome to the part 3 Heat and Temperature. Already we discussed what is heat and what are the modes of heat of transfer. Yes, today we will discuss temperature and the device which is used to measure temperature and the different scales that are available in the thermometers. Right? What is a temperature? Temperature is a measure of degree of hotness or coldness of a body. So, if I give a heat to a body, obviously how much the body absorbs heat and how much the body loses its heat, we need to measure. So, that measurement we call it as temperature, degree of hotness or coldness of a body. Temperature is a physical quantity. Temperature is a physical quantity. It is a physical quantity and it is also a fundamental quantity. Physical and fundamental quantity. What is a physical quantity? Any quantity which can be measured, we call it as physical quantity. Can be measured is called a physical quantity. A fundamental quantity is an independent quantity which is so fundamental quantity. Fundamental quantity is a independent independent quantity, right? Independent quantity. That means it cannot be expressed in any other form. This is here temperature. And thermometer is a device which is used to measure temperature. And we have different types of thermometers. Clinical thermometer, which is used by doctors to measure human body temperature. Laboratory thermometer, which is used to measure in labs boiling point and freezing point. What is BP? Boiling point. Boiling, uh, boiling point and freezing point. Freezing point. So, to measure the boiling point and freezing point of a liquid, they will measure, they'll use the laboratory thermometers. Digital thermometers, thermometer is used to measure the body temperature as well in laboratory purpose, but used in that we run, ఎలా రన్ అవుతుంది ఇఫ్ యూ యూస్ ఆ బ్యాటరీస్. అదే క్లినికల్ థర్మోమీటర్ laboratory థర్మోమీటర్ అనుకోండి, నో నీడ్ ఆఫ్ ఎనీ బ్యాటరీ, దే కెన్ రన్. సో మీరు మెర్క్యూరీ ఉంటుంది, మెర్క్యూరీ బేస్ చేసుకొని దే విల్ రన్. బట్ ద డిజిటల్ థర్మోమీటర్ మాత్రం we need to take the support of battery. Tympanic thermometer. Tympanic thermometer means that we use to test the temperature inside the ear canal or to test the ear problems, right? This is the different types of thermometers. What are the clinical thermometer, laboratory thermometer, digital thermometer and tympanic thermometer, right? Now we will move to the, see, these are the different types of thermometers that we used in laboratory. If you see this, can you see this red mark? And this is called bulb. See, what is this? This is called bulb and this is a mercury, whatever it is, having a red mark. In all this, yes, they'll use a mercury or alcohols. Mercury, mercury or alcohol they use to measure, right? These are the different types of laboratory thermometers that are used to measure boiling point and freezing point. Now, digital thermometers. So, digital thermometers are, see, this is the digital thermometer which will run based on the battery, and this is the electronic tympanic thermometer which is used for inside the ear canal. Now we will see the simple drawing of the thermometer. If you see the simple drawing of the thermometer, yes, it is having a glass tube. So what is this outermost? This is the glass tube, and this is called a bulb. That bulb is containing a mercury. Bulb is containing a mercury, and whatever this we call it as capillary tube. What we call it as capillary tube. And in the capillary tube there will be a mercury, and if I want to measure the body temperature based on the temperature, it will raise the level of the mercury. It will raise the level of the mercury, and we can measure the reading. If you see this, see what is this? A U-shaped. Have you observing that U-shaped one? Yes. What is this U-shape? Why for this? This is U-shape. We call it as kink or constriction. Kink or constriction. Why we use this means, ఇప్పుడు మీరు రీడింగ్ తీసుకున్నారు అవునా, తీసుకున్నప్పుడు ఇలా రేజ్ అయ్యింది, ఆబ్వియస్లీ మనం తీసేసాక టెంపరేచర్ ఉన్నప్పుడు రిటర్న్ వెళ్ళిపోతుంది కదా. అలా రిటర్న్ వెళ్ళకుండా ఈ కింక్ అనేది ఏమవుతుందంటే ఇట్ విల్ స్టాప్ ద బ్యాక్ ఫ్లో టు టు స్టాప్ టు స్టాప్ back flow of mercury, back flow of mercury, because mercury is very sensitive to the temperature. Even if there is a small change in the temperature, yes, the readings, the level will be up and down. So if immediately if I remove from the person, so obviously that mercury will cool down and it will flow to the back. So to stop black flow of mercury, we have this kink or constriction. And you may have a doubt that, ma'am, in this we are having kink, but whatever the diagrams you showed for laboratory, we don't have kink. Why? Because in laboratory thermometer, so we will measure the temperature. See if it is a vessel, so we will insert the thermometer and we will measure directly. So no need to remove this thermometer out and to measure. So we don't require any kink in the laboratory thermometer, but in clinical thermometer, obviously we cannot measure by the person is holding in his tongue. We cannot measure the temperature. So obviously if we need to remove from his mouth. So obviously the temperature will vary, and there is a chance of the back flow of the mercury. So to avoid that back flow, so we'll use this kink or constriction. That means, so even have you observed that in doctors thermometers normally they will shake it so that to bring down the mercury level back, so it will not come back easily. They'll place into the water, they'll slowly reduce, and again they'll shake to bring the original level of the mercury, right? Now this is the thermometer, a simple drawing of thermometer. Now Kelvin. So here can you see this three different types? Here the three we call it as thermometers. These three are thermometers. These three are we call thermometers, right? This thermometer, if you observe it, yes, they are all equal in size. All are in equal in size. Only the difference is scale. Only the difference is scale is different in this thermometers. Have you seen that? Same size, same height, same shape, same diameter. Only thing is scale is different. What is this? Scale. So here when I use this Kelvin, I'll call it as Kelvin scale, Celsius scale and Fahrenheit scale. Kelvin. So here what's the difference between Kelvin scale, Celsius scale and Fahrenheit scale? What is the difference? The difference is, see, for any thermometer we need to have 2 points. One is upper fixed point, UFP, upper fixed point, and other one is lower fixed point, right? What is the meaning of UFP? Upper fixed point, and other one is, this one is lower fixed point, upper fixed point and lower fixed point. The upper fixed point and the lower fixed point is different in different scales. In Kelvin scale, the upper fixed point is 373 Kelvin. In Celsius, fixed point is 100 degree Celsius. And in Fahrenheit, the upper fixed point is 212 degrees Fahrenheit. The lower fixed point in Kelvin scale is 273. In Celsius scale is 0 degrees, and in Fahrenheit it is 32 degrees Fahrenheit. What is this upper fixed point? Is called boiling point of water. BP. What is this BP? Boiling point of water. See, at which point the water boils is called upper fixed point. So, what is the water boiling point? 100 degrees Celsius. So, in Kelvin it is equals to 373. In Fahrenheit it is equals to 212 degrees Fahrenheit. The lower fixed point we call it as freezing point. What we call freezing point. That freezing point or called melting point of ice. Freezing point of water or melting point of ice. Both are same, right? Now the lower fixed end point of water is 0 degrees Celsius. In Kelvin, it is equals to 273, and in Fahrenheit, it is equals to 32 degrees Fahrenheit. And the absolute zero value in Kelvin scale is 0 Kelvin, that is equals to 273 degrees Celsius, and that is equals to minus 459 degrees Fahrenheit. And can you see that other one, the human body temperature? What is the human body temperature? You know, 98 degrees Fahrenheit. That equals to 37 degrees Celsius, and that 37 degrees Celsius is equals to 110 Kelvin. How these values are equal? We have a formula to calculate, to convert. So if I know the value in one scale, I can convert into other scale, and I need to have a relation. See, for that, simple thing is whatever the temperature, whatever the scale you are taking, the temperature in the scale minus lower fixed point value divided by upper fixed point minus lower fixed point. This is the formula. So if I want to compare the two scales, think if I want to compare the Kelvin and the Celsius. So temperature in Kelvin is equals to temperature in Kelvin minus lower fixed point divided by upper fixed point minus lower fixed point. Temperature in Celsius minus lower fixed point divided by upper fixed point minus lower fixed point. Right? Now I'll show the how the relations we will develop between the three scales. Now see here, the temperature in Kelvin scale minus lower fixed point divided by upper fixed point minus lower fixed point, that equals to temperature in Celsius minus lower fixed point divided by upper fixed point minus lower fixed point. So we have one more scale. What is that scale? Yeah, Fahrenheit. Temperature in Fahrenheit minus lower fixed point divided by upper fixed point minus lower fixed point. If you remember this, yes, you can. So now I need to measure, I don't know the temperature. That is x value. That T suffix k is an x value. Whether I should convert into one form to other. What is the lower fixed point in Kelvin scale? 273. That is the freezing point of water. And upper fixed point is 373 minus lower fixed point is 273. That equals to temperature in Celsius minus what is the lower fixed point in Celsius scale? 0. And what is the upper fixed point in Celsius scale? 100. 100 minus 0. That equals to temperature in Fahrenheit minus what is the lower fixed point? That is 32 degrees Fahrenheit divided by 212 minus 30. Right here, the difference in the lower fixed point and upper fixed point gives a number of divisions. Number of divisions of that scale. Number of divisions. See, if I take a scale, you have centimeter scale. So it starts with 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and up to here we call 1 centimeter. So what is our division of the scale? Our scale divided 1 centimeter is equals to 10 divisions, and 1 each division we call it as mm, right? So therefore 1 centimeter is equals to 10 mm. So how many divisions here? We are having 10 divisions. So how can I, so what lower here, what is the lower fixed point here? 0. And what is upper fixed point? 1. So how many divisions between? There are 10 divisions. Similarly, for every scale, how many divisions depends upon the difference in the lower fixed point and the upper fixed point. Here, if you take that, so temperature in Kelvin minus 273 divided by 373 minus 273 is equals to 100. There is a difference in, that is, number of divisions in Kelvin scale is 100 divisions. Temperature in Celsius, 0, leave it, 100 minus 0, 100. So how many divisions in Celsius scale? In Celsius scale also there is 100 divisions. That is equals to temperature in Fahrenheit minus 32. And what is the difference between 212 and 32? 180. See, 212 minus 32. 0. So we will get 11. So 1. So if I borrow 1, I'll get 11 and it will get 1. 11 minus 3, 8 and 1. So what is the number of divisions? 180. So number of divisions in Kelvin scale is 100. Number of divisions in Celsius scale is 100. Number of divisions in Fahrenheit scale is 180. Now, so this is your relation between the three different scales. You need to remember this. Now, see. Now, here, if I want a relation, think that, so I know the temperature. So the temperature in Kelvin minus 273 divided by 100 is equals to temperature in Celsius divided by 100, that equals to temperature in Fahrenheit minus 32 divided by 180. We got this relation. Now try to build up a relation between Kelvin and Celsius. That means if you know the value in Celsius, you can calculate in Kelvin. If you know the value in Kelvin, you can convert into Celsius. Now, if I try to build the relation between the Kelvin and Celsius, 270 temperature in Kelvin minus 273 divided by 100, that equals to temperature in Celsius divided by 100, that I am taking the first relation. Now send this 100 to this side. So what you will get? Temperature in Kelvin minus 273, that equals to 100 divided by 100 into temperature in Celsius. 100 gets cancelled. Therefore, temperature in Kelvin minus 273, that equals to temperature in Celsius. This is your first relation between Kelvin and Celsius. Now try to calculate other relation between Kelvin and Fahrenheit. Temperature in Kelvin minus 273 divided by 100 into temperature in Fahrenheit minus 32 divided by 180. Send this 100 this side. So temperature in Kelvin minus 273 is equals to 100 divided by 180 into temperature in Fahrenheit minus 32. 0, 0 gets cancelled. 2 5s are 2 9s are 18. Therefore, temperature in Kelvin minus 273 is equals to 5 by 9 into temperature in Fahrenheit minus 32. Therefore, temperature in Kelvin is equals to 5 by 9 into temperature in Fahrenheit minus 32 minus 273. That is, this whole value is subtracted by 273. This is your second relation between Kelvin and Fahrenheit. That means if I know the value in Fahrenheit, I can convert into Kelvin. Now we will try to build another relation between. So we completed Kelvin and Celsius, Kelvin and Fahrenheit. Now it's turned to Celsius and Fahrenheit. Temperature in Celsius divided by 100, that equals to temperature in Fahrenheit minus 32 divided by 180. Right? Temperature in Celsius, send this 100 this side, that equals to 100 divided by 180 into temperature in Fahrenheit minus 32. 0, 0 gets cancelled. 5 by 9. Temperature in Celsius is equals to 5 by 9 into temperature in Fahrenheit minus 32. This is your third relation to convert Fahrenheit into Celsius, right? So these are the three relations. So remember this relations, they'll ask for the MCQs, and even if you want to convert conversions, yes, if you remember this formula, you can directly substitute. Otherwise, you need to do the all the processes once again. It's time taking process. Now, so now we know the relations, right? Now we will try to convert Fahrenheit. So we know the human body temperature in Fahrenheit is scale is 98 degrees Fahrenheit. So try to convert into Celsius and try to convert into Kelvin. So if I want to convert Fahrenheit into Celsius, so we know that Fahrenheit Celsius is equals to 5 by 9 into temperature in Fahrenheit minus 32. Already we developed the relations. 5 by 9. Substitute the Fahrenheit value 98 minus 32. 98 minus 32, that value equals to 66. What is the value? 66. 3 3s are 3 2s are 22 into 50, 110 divided by 3. That equals to 36.666. So it will continue bar. That equals to 36.66 bar degrees Celsius. That is approximately equals to 37 degrees Celsius. Now try to calculate the human body temperature in Kelvin. So temperature in Kelvin is equals to 5 by 9 into temperature in Fahrenheit minus 32 minus 273 plus 273. Now that equals to, can you see this 5 by 9 into temperature in Fahrenheit minus 32? This is this value similar. And how the value calculator? 37 degrees Celsius plus 273. 37 plus 273, how much? 273 plus 37, 10, 11, 310. That is equals to 310 degrees Kelvin, right? Now, so according to this, the temperature in Celsius, the human body temperature is 37 degrees Celsius. In Kelvin, that is equals to 110 degree Kelvin. And in Fahrenheit, that is equals to 98 degrees Fahrenheit. This is the way to convert one scale into other scale. Here you can convert you can write this entire term as Tc plus 270. This is another relation. Yes, easy to remember. Temperature in Kelvin is equals to temperature in Celsius plus 273. Directly you can add 273 so that you will get the temperature in Kelvin. So now try to convert. So we have gave the relations. So try to convert 53 degrees Celsius into Fahrenheit. For you few I'll do it, remaining you practice it. So first try to convert 53 degrees Celsius into Fahrenheit. Which formula I need to use? So I need to use the first formula. What is the formula? Temperature in Fahrenheit is equals to C into C into 9 by 5 plus 30. How this relation came? Already we derived temperature in Celsius is equals to 5 by 9 into temperature in Fahrenheit minus 32. So they send this 5 by 9 here, that became 9 by 5 is equals to temperature in Fahrenheit minus 32. Send this 32 this side, minus will become plus. So temperature in Celsius into 9 by 5 plus 32 is equals to temperature in Fahrenheit. This is the way. So similarly, this formula also they gave. Okay. Now convert the first problem. 53 degrees Celsius formula, temperature in Fahrenheit is equals to, what is the Celsius value? 53 degrees into 9 by 5 plus 32, that equals to 9 3s are 21. So 9 into 9 into 53. 9 3s are 27. 9 3s are 27. 9 5s are 45. 47. So 477 divided by 5 plus 32. Right? Divide 477 with 5. 5 9s are 45. 2 7. 5 5s are 25. 2 point, so 0 5 fourths are 20. So what is the value? 15, sorry, 95 minus 4.95.4 plus 32. Add it. 0.4 you'll have the same. 5 plus 2 7. 9 plus 3 12. How much? 127.4 degree Fahrenheit. 53 degrees Celsius is equals to 127.4 degree Fahrenheit. Right? Now, so similarly, try this remaining. The procedure is same. So substitute and try to convert one form of the scale into other form of the scale. I hope you understand how to convert. Now we will discuss the difference between heat and temperature. What is heat? Heat is a form of energy, and temperature is a measure of degree of hotness or coldness. And units of temperature is joule and calorie. SI or MKS unit of joule, heat is joule. Calorie is the Celsius unit. Calorie is the Celsius unit. And what is the SI unit of temperature? Kelvin. Kelvin is the SI or MKS unit. And Celsius and Fahrenheit are the Celsius units of temperature. Heat is always positive. That means heat is called energy. Energy move from hot body to cold body. So always the body will absorbs energy. It will not lose the energy. Always it absorbs the energy. That's why it is always positive. But the temperature may be positive or may be negative. Why? Because yes, if heat is absorbed, the temperature will increase. If heat is lost, if heat is lost or if heat is released, the temperature is decreased. So if heat is absorbed, temperature is increased. If heat is released, temperature is decreased. So if heat is absorbed, temperature is positive. If heat is released, temperature is negative. And here heat goes from hot body to cold body, but rises when heated, falls when cooled. Already we explained in the previous point. And what is a device which is used to measure heat? Calorimeter. And thermometer is a device which is used to measure the temperature. Right? Now, already I said that we use mercury as a liquid in the thermometer. Apart from mercury, we use the alcohol also. So mercury and alcohol are the two liquids, even water sometimes we used in the thermometers. But apart from water, the best results are from mercury and alcohol. We will discuss why. Here, why we use mercury as a thermometer liquid. Why? Mercury gives very accurate values. So accurate values are given by mercury. Why they'll give accurate values? Because mercury is sensitive to more sensitive to heat. That is, even the small change in the temperature, it will expand. Sensitive for heat. So for small change of heat, mercury will expand. Second thing is, it is shiny in appearance so that we can see easily the reading, and it will not stick to the walls of the container. It will not stick to the walls of the wall of the container. So in capillary tube, it will not stick to the container. And other most important thing is, mercury is the only metal which is in a form of liquid at room temperature. So this is a metal, only metal which is in the form of liquid at room temperature. So this is the reason why we prefer mercury in thermometers. One is it will give accurate values. It is sensitive for heat. That means for small changes of heat, it will expand. It is shiny so that reading will be clear, and it will not stick to the wall of the container, and it is one of the metal. So it is only the metal which is a form of liquid at room temperature. Now we will compare the mercury and alcohol. Mercury, it has high boiling point. Mercury is having high boiling point. That boiling point is equals to 357 degrees Celsius. So I can go for measuring high boiling point. But alcohol is not having that much high boiling point, but it's having a low boiling point. It is 78 degrees Celsius. So we can measure low temperatures in alcohol. We can measure high temperatures in mercury, and it has relatively higher melting point, and it is having it has a low melting point, and it is a good thermal conductor. The conductor means which allows heat to transfer to it. But alcohol is a poor thermal conductor. Yes, it allows, but it takes a time. It expands regularly. The expansion is regular, but its expansion is slightly irregular. It does not wet the glass. That means it will not stick to the wall of the container, but it wets the glass. It is opaque and silver. It is not transparent so that we can see the readings clearly, but it is transparent and therefore has to be colored to make it as visible. If we are not adding color, yes, we cannot see them clearly. So this